Okay, so I'm gonna keep teaching. We're gonna go, I think, to part 5 now of applications of differentiation. I'm just gonna keep. I'm gonna show a few more examples, or at least maybe one more example of discussing the concavity of the graph and the domains and the critical points and stuff. So, got another function here. Okay. X to the fourth minus 4x cubed. So the first derivative with respect to x is going to be 4x cubed minus 12x squared. The second derivative will be 12x squared minus 24x. Okay, so let's find the critical points. Okay, let's find a place where, yeah, actually the critical points for the critical x values for the first derivative when this is going to be 0. Okay, let's see here. I can do 4x 4x squared. I'm just factoring out the 4x squared from this formula. So this is going to be x, x minus 3, okay, equal to 0. So you can say that x equal to 0 and x equals 3. Okay, so it's going to be 0 and 3. These are critical points. I mean, this stuff is when the first derivative is 0. What about the second derivative? When is it 0? I'm going to factor out 12x from it. Okay, so you got x in here minus 2. So x equals 0 and x equals 2. Okay, so I'm just going to put, like, for the second derivative, a critical x is when x equals 2. Okay. When x equals 0 is also, but you know, yeah, I'm gonna put 0 and 2 here. 0 and 2, because this is gonna be interesting. So, what about the domains? So we got a domain here, minus infinity all the way to, well, the first thing here is 0. And then you got the 0 point, and then from 0 all the way to 2, then you have a 2, and then you have from 2 all the way to 3, and then you have a 3, and then from 3 all the way to infinity. Yeah, you got all these critical points in here in the domain. Okay, so from between minus infinity and 0, well, let's see, for example, minus 1. Oh, the slope in here is not going to be 0, okay? Because the first derivative is only 0 as 0 and 3. So, what's going to, between, in this domain in here, all right, there's going to be a concavity up or down. Why? Because the first derivative is less than 0. The first derivative is not 0. Okay, so if it's not 0, there's a slope either up or down, and there's a concavity up or down. So how do we know that? Well, let's see minus 1 in here. Minus 1 is going to be 12 plus 24. So it's a positive number. Okay, if it's a positive number, the second derivative is a positive number, the concavity here is up. Concavity is up. Now at 0, here's something interesting. You see, the first derivative is 0, and the second derivative is also 0 at 0, at the point 0. Okay? So I know that this is a flat tangent line, but we gotta find out what's going on in here. So let's go to this one. Okay, between 0 and 2, let's try, for example, 1. Between 0 and 2, the first derivative is not 0, so you know that there's a slope up or down. Let's see the concavity. For example, let's put 1. It's going to be 1 is going to be 12, okay? Minus 24. So the second derivative is 0 in this domain here. So the second derivative is negative in this domain here. So we know the concavity is down. Okay, so you got a concavity up, and then you come here, and then you got a concavity down. Okay, you come to 0, and then you have a down concavity like this. Okay, because you could have something like that, but that will be an up concavity. So it's a down concavity. So we know that this 0 here has to be a minimum. Okay, there's another thing too. You got a positive slope in here and a negative here. Let's try that. What's the first derivative in here? The first derivative, for example, minus 1 in this domain. Okay, to see if the tangent is positive or negative. So you got a minus 4 here, okay, and then you have a minus, if it's a 1, minus 1 squared 1 times minus 12 minus 12. So you got actually a negative slope in here. Oh yeah, that's right. You got a negative slope. So this is going to be a minimum. You got a negative slope in here, and then you got a down concavity, so it has to be like that. So this is not a minimum or anything. Okay, you got a negative slope in here. Let's put the slope is negative. What about here? The slope, what's it gonna be? Okay, well, let's put a 1. So it's gonna be 4 minus 12. So it's gonna be minus 8. So the slope is also negative. So the slope is also negative. What does that tell us about this? Okay, you got a negative slope with an up concavity. So you got something like that. And then you got a negative slope with a down concavity, something like that. Okay, so what is this 0? This 0 is nothing. All right, this thing here, this is nothing. There you go, nothing. All right. Now let's see the 2. The 2 is going to have a slope different than 0. Okay, so here we go. It's going to have a first derivative at 2. At x equals 2, the first derivative is going to be different than 0. So it's going to be like this or like that. But the second derivative is 0. That means that it's an inflection point. If this is the concavity down, this thing here has to have a concavity up, according to theory. But let's see if it does have a concavity up. Let's put, for example, 2.5 in the second derivative here. So 2.5 is going to be 12 times 2.5 is 5 over 2. So it's going to be 25 divided by 4. Okay, it's 5 over 2 squared, so it's going to be 25 divided by 4 minus 24 times 5 divided by 2. So this becomes a 12, okay, this becomes a 3, and what do you have? You have a 75 minus 60. All right, so it's positive. So there you go. It's positive. That means the concavity is up. Look, see, just like the theory says. Now let's see what's happening here in 2 by inspection. Okay, so you have a negative slope and a concavity down like that. Okay, like that. And then at 2, I said that it was an inflection point. So at 2, which is kind of like here, you got to start having a concavity up like that, okay? And at 3, the tangent's going to be 0. So here, at this point here, this is going to be x equals 2, and this is going to be x equals 3, okay? It starts having a concavity up. Well, in this point, the concavity is up, right? Now, what is happening over here in this domain? Well, let's see. At 3, this is 0, okay, but the second derivative is not 0. So let's see what's happening when you put a 4 here. Well, 4 is 16, so it's going to be 12 times 16. Not so good at doing this. 12 times 16. That's going to be 120 plus 72, 192, I guess. 12 times 16. 12 goes 1, 72, and another 1. So you get a 2 here, a 9, okay, yeah, 192. So at 4, if you plug 4 here, 16 times, okay, 192, okay, minus 4 times this, which is going to be 96. Yeah, so it's positive. So the concavity, okay, according to the second derivative test in here, the concavity is up. So you see what you have here? You have a concavity up here. At 3, you got a tangent of 0 because the first derivative is 0, and then you have a concavity up. So it's like that. All right? And let's see if it is if the concavity is up in here, the tangent has to be positive too, right? Because the tangents are going up in here. So let's see if that's the case. You put this value of 4 in here. Man, this is going to be tough. So it's going to be 64 times 4, that's 256. Okay, minus, it's a 4, right? So it's a 16 times 12, which was 192, right? We just remember that. So it's positive, and so you have a positive tangent, and here you have a positive tangent, and that's the graph. The graph is like this. Okay, you got an inflection point in here. So let's just say that this is inflection point, or point of inflection, and the 3, it's going to be a minimum, right? Oh yeah, 3, it's going to be a minimum because you see at 3, the first derivative is 0, and the second derivative, I bet it's going to be positive. So it has to be a minimum. So let's see. Let's put a 3 here. It's going to be 9. Okay, so 90 plus 18 is going to be, I think, 108. Right? Minus, you put a 3 here. It's going to be 72. So it's positive. So if this is positive, the second derivative is positive. When the first derivative is 0, it's a minimum point. And look at that. You got a minimum point here. Okay, so this is a minimum. So the first one here, 0, is nothing. The second one is a point of inflection, okay, and the 3, 1 is a minimum. Now let's see, look, this graph, okay, yeah, over here, okay, because this 0 through, at 0, it's also going to be a 0, so I'm just gonna kind of erase this in here, and I'm gonna keep going, la 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 la, and there's gonna be a 0 here. Okay, this is a point 0, and I found out that the slope is negative, but the concavity is up. So the graph does this. Okay. So it comes, it goes down, and you can see that the 0 here is not a maximum or a minimum, it's just nothing. So you come here, down the slide, you have a little break, then you keep coming down the slide in a negative in this part here, you got a negative concavity, then you have the point of inflection at 2, then you have a positive concavity, and you keep having a positive concavity. I mean, an up concavity. Here you got a down concavity, up concavity. So it's up, down, up, up. Now let's see. So this is the graph, okay? This is the graph. Let's see if this is what the exercise shows. It is. Look at that. Okay? So look at this stuff in here. You're going down here, you're going down here, and then you have a 0, you have a 0. Then you keep coming down up to 2. You keep coming down up to 2, and it says points of inflection. Oh yeah, you can say that the 0 is also a point of inflection because, right, it's not a minimum or a maximum, but it's a point of inflection, okay? Because it's coming from down concavity to up concavity. So I said that it was nothing here, but it's something. I can just erase this nothing. It's just not a minimum or a maximum, but it is a point of inflection. All right. And now coming back to the graph. So you got a point of inflection here 0, you got a point of inflection here 2, because it's going from down concavity to up concavity. You got a minimum at 3, and then it keeps going up. And there you go. Let's just see another one here. This one's going to be easy. F of x equals x to the 4th. So the first derivative equals 4x cubed. The second derivative equals 12x squared, right? So what is the critical point? The critical point is just x as 0. And this here, the second derivative, also has x as 0, right? So let's see. We don't know if this is going to be up concavity. Well, yeah, up concavity, down concavity, minimum, maximum, we have to analyze. Now let's see. Before the domains, okay? So the domains you have from negative infinity all the way up to 0, and then you have 0, and then you got from 0 to positive infinity. Let's put minus 1. If you put a minus 1 here, all right, it's minus 1 times 4, minus 4. So the slope in here goes down. The slope is negative. A minus 1 in here is just going to be 1, okay, times 12 is 12. It's positive, so the concavity is up. Okay, at 0, we just don't know. We're going to have to evaluate the whole thing, okay? Let's just say from 0 to 1. Well, this is going to be 1, so the slope is positive. And at 1, this is going to be positive, so it's an up concavity. So you see, this is negative a slope. And in here at 0, you got a critical point where the tangent equals 0. And then you have a positive slope, so you have a graph like this. Okay, here is the point 0, and you got something here, so this is a minimum. Now, here you got an up concavity, and here you also got an up concavity. So this thing here, the 0, is not a point of inflection, but it is a minimum according to the first derivative test. Here you got a negative slope, and here you got a positive slope. So this is a minimum. Okay? And let's see if this is what the book tells us. Look at the graph. There. See? Okay. Let me see here. I'm thinking, guys. Okay, let's try another one. As they say, practice makes perfect, right? Practice makes perfection. So f of x equals minus 3x to the fifth plus 5x cubed. So the first derivative equals minus 15x to the fourth, right? Plus 15x squared. I'm just gonna already do this, so it's 15x squared, okay? It's gonna be minus x squared plus 1. I'm just factoring out the 15x squared, okay? Minus x squared plus 1. Or I can do this, yeah, I think I better do this. I'm gonna do minus 15 here. So this is gonna become a positive, and this one becomes a negative. It'll just make it even easier. Okay? Okay. Yeah. Now you got a second derivative here, which is minus 60x cubed plus 30x. And I think I'm gonna do the same thing here. Okay, minus 30x. So this is gonna be 2x squared. Yeah, 2x squared minus 1. All right. So let's find the domains. Oh, well, I gotta find the critical points, right? X critical here. So when is this stuff gonna be 0? Well, at x equals 0, and at x equals plus and minus 1. What about this? When is this gonna be 0 here? Well, at x equals 0, it's good to do this, guys, right? And there's something else here. You got 2x squared minus 1 equals 0. 2x squared equals 1. X equals plus or minus the square root of half, right? So it's gonna be plus or minus 1 divided by the square root of 2, and I think it's called radicalizing the denominator. You're gonna multiply everything by square root of 2, so there's gonna be plus or minus square root of 2 divided by 2. So we put that in here, plus or minus square root of 2 divided by 2. This is approximately this stuff in here. Okay. I'm gonna do this. This is approximately 0. Well, let me think here. I think it's 0.707. Let me think here, guys. Let me just... I'm trying to find something. It's approximately 0.707. Approximately, okay? Kind of like that. Okay, so let's do this. So you have a domain, okay, from negative infinity all the way to, what's the smallest number here? I think it'll be -1. Then you have a 1, and then from 1, actually, although you got a -1 here, and then you got a -1, okay, all the way to negative 7.7, yeah, negative square root of 2 divided by 2, and then you have the square root of 2 divided by 2, and then you have square root of 2 divided by 2. Actually, it's negative, right? Negative here, negative here. All the way to 0, and -1 to minus and then you got this, and then you got here all the way to 0, and then you have 0, and then from 0 all the way to square root of 2 divided by 2, and then you have square root of 2 divided by 2, and then you have from square root of 2 divided by 2 in an open interval all the way to 1. You have 1, and then you have from 1 all the way to infinity. Yeah, you gotta break the graph in here in many. Okay, so let's think. Let's see. This domain in here. Let's put -2. Okay, well, you see over here there's gonna be a slope. Okay, so let's see if it's concave up or down. If you put a -2 here, this is gonna be a positive number. -2, okay, so it's gonna be -8, right? It's gonna be 480 positive minus -2 minus 60. So this is gonna be positive. So this is concave up. All right. And the slope, yeah, we gotta find the slope. -2. Well, putting a -2 here, this is gonna be a negative number. Yeah, I'm really gonna have to do this. So a -2, it's gonna be 16. 16 times 15. Well, it's 256. Let me think. 256 minus 16, 240. So I'm just gonna guess, okay? I think that this is gonna be -240 when you put a -2 here, because -2 to the fourth, 16. 16 times minus 15, -240. Okay, and then you have a plus, and you see you got a 15 in here. So, but it's times 4, so it's plus 60. So this is going to be negative. So the slope is negative. The slope is negative. So you know you have a negative slope with a concavity up. So it's like that. Okay. But we got to find these things. Okay, a -1, this thing is going to be 0. But the second one, the first derivative is going to be 0. But the second derivative is not going to be 0. All right, so a -1, let's see. -1, okay, so it's going to be 60 and minus 30. So it's a positive at minus 1, the second derivative is positive and the first one is 0. So this is a minimum. Okay, now we're talking about this domain here. Okay, minus 1 all the way to negative square root of 2 divided by 2. Well, you see, if this is a minimum, that means that the concavity here has to go up, okay? And the slope has to be positive. The point now is how we prove that, because this is a little kind of pain in the butt. You gotta find a number between minus 1 and minus 0.707. Let's put, for example, minus 0.8, which is minus 8 divided by 10, which is minus divided by 2, minus 4 divided by 5. Let's try that. Minus 4 divided by 5. So, minus 4 divided by 5. In here. So you got minus 15 minus times minus 4 divided by 5. So it's going to be 16. Okay. In here, you're going to have 5 to the 4th. I think it's 625. Let me guess. Let me make sure. Yeah, it's 625. So over here we're gonna have, okay, that's here. Now plus 15, and then you have minus, right? 4 divided by 5, but it's gonna be 16 over 25. Okay. And then you have to find out if this is going to be positive or negative. Oh no, this is not going to be 16. It's going to be 16 times 6. Yeah, it's 4 to the 4th. So it's going to be 256. 256. Okay. Okay. If you square this stuff, you're going to have a 625, and if you square this, you're going to have a 256. But would you say that it's the same? No, it can't be. Oh, no, it can't be. No, yeah, you can't do that. Now, I'm going crazy here. Okay. So let's see here. I'm just going to do this using calculator. You guys can do this by simplifying things and stuff. I'm just going to use a calculator. Okay, so I'm going to do 156 times 15 divided by 625. You got a 6.144 here, but it's negative 6.144. Okay, now plus. You have 240 divided by 25. 9.6. 9.6. So this is positive. So there you go. I was applying, guys. What am I doing here? I'm applying the number minus 4.5, which is in the middle of this domain here. Okay. I'm applying this in this formula, and what did I find out? I found out that this thing here is going to be positive. If it's positive, it's a positive slope. Okay, so right now it's working. Okay, and the concavity is up. For the concavity is up, when you put more minus 4 divided by 5 in here, it also has to be a positive thing. Okay, so let's see if it is. So you have minus 60 times 4 divided by 5 cubed. So it's 64 divided by 125 plus 30 times 4 divided by 5. Actually, it's minus 40 divided by 5. Yeah, since it's minus 4 divided by 5, it's going to be a negative here. With this negative, this is going to be a positive. And here you got, this is going to be a negative. Because I'm just going to put a negative here. Okay, so let's see what this comes up to. Okay. I'm going to use a calculator again. 60 times 64 divided by 125, that's 30.72. So you got a 30.72. Now remember, according to the theory, this operation here, not this operation, this equation here has to be positive. Okay, now here you're going to have a minus 120 divided, well, you can see that this is going to be a 6 minus 24. There you go, 30.72 minus 24 is positive. That means that the second derivative is positive, so the concavity is up. See? Okay. Now we have here, at this point, the first derivative is not going to be 0, but this derivative is going to be 0 because we discovered it over here. Okay, if you put for example, I just want to prove to you guys, negative 60 times square root of 2, well, it's going to be negative. Okay, now square root of 2 to the cubed, right? What is this going to be? This is going to be 2 square root of 2, square root of 2 cubed, and then you have here 8, all right, plus 30 times negative square root of 2 divided by 2. All right, so this is going to be negative some. Okay, let me just think here for a second. So this is going to be a positive thing. Okay, it's going to be 120 square root of 2 divided by 8, so 60, 30, 15. I'm just going to put a 15 in here. 15 square root of 2, okay? And here you have a negative, and this is going to be minus 15. Look at that, because you do this, right? So minus 15 square root of 2, so that's 0. There you go, it's proven. It's proven that plus and minus square root of 2 divided by 2, it makes the second derivative 0. So here you go. You have a first derivative and minus square root of 2 divided by 2, which is not 0, and you have a second derivative, which makes it 0. So this could be a point of inflection. Yes, this could be a point of inflection. Well, yes, it's gotta be a point of inflection, guys, because let's see, it becomes negative, then it becomes 0, okay, like this, and becomes 0, and then it becomes negative again. I don't know, that doesn't sound right to me. Let's see what happens here. Okay, so you got minus 707 and 0 here. You need a number here, like minus 0.5. So minus half is going to be within this domain here. Okay, so let's put minus half. Minus half in the first derivative is going to be minus 15 minus half, so it's going to be 1 over 16. Okay, plus 15 over 1 over 4. Okay, so you got minus 15 over 16 plus 15 over 4. So you multiply this stuff in here by 4, you get 16. You multiply this stuff in here by 4, you get 60. So 60 minus 15 is going to be 45. So this operation, this equation is going to be a positive number. So if this is positive, okay, so you gotta, let's see here. So this in here, the slope is positive. So you got a positive slope in here in a concavity up like this. And then you have something that's gonna be 0. And then you still have a positive slope, but you gotta have a, oh yeah, you got a positive slope and a concavity up like that, so it's this. And then you have a point of inflection here, I think, at minus square root of 2 divided by 2. And here you have a positive slope, but probably a concavity down. Let's see. But I think the concavity, I'm just going to assume that concavity here is down. Okay, let's see if it is down. So we're going to put minus half in the second derivative. If it's negative, if the equation is negative, when you put minus half in here, then you know that the concavity is down. So minus half, okay, in here is going to be minus 1/8, so it's going to be 60 divided by 8. Minus 30 to minus 15, okay? So if you are going to, you're going to divide this by 8 in here, you got to multiply the stuff over there by 8, see? You do this, you have to multiply this to 8. So 80 plus 40, 120. 120. So it's going to be negative 60 over 8, which is negative. If it's negative in the second derivative, that means that the concavity is down. Look at that. Okay, so here we have again proof, okay? When you have a first derivative, which is not 0, and a second derivative, which is 0 at x equals a certain point, the point is a point of inflection. And it is, look, you have a positive concavity, an upward concavity here, and a downward concavity here. A positive slope and a positive slope. So this is what you have. Okay, you got something like this. And this point right here equals minus square root of 2 divided by 2. Look, you got a positive slope before and a concavity up. You got a positive slope later and a concavity down. Okay, so this is a point of inflection. 0. 0 makes the first and second derivative 0. Okay, so you cannot use the second derivative test. You're going to have to go for the first derivative test. So to find out what this is. So let's see. Let's put half in here. Half is within this domain. Okay, so let's put in here. So half is going to be minus 15 in the first derivative. Minus 15 divided by 16. Okay, plus 15 divided by 4. Now multiplying this by 4, you get a 16. Multiplying this by 4, you get a 60. And this is 45 divided by 16. So it's positive. So I know that in here, the slope is positive. Okay, now let's try to visualize this. Okay, you get a positive slope and a concavity down. So it's coming like this. And then you have 0. And then you have to have a positive slope in here. So what does that tell you? It tells you that this is really nothing. Well, it is a point of inflection, yes. because you're going to have a positive slope in here, so you got a down concavity and then you have an up concavity. This, I can say that it's a point of inflection. Well, let's see. If it's a point of inflection, this concavity has to be upward. Let's see if it is upward. How do we know that? Let's put half in this equation here, and let's see if it's positive. Okay. We have minus 60 times half cubed. So it's divided by 8 plus 30 divided by 2, which is just half, is 15. Okay, now you want to put an 8 here, so you got to put 120 here. And this equals 60 divided by 8. So the second derivative is positive. If it's positive, you know that the concavity has to be up. Okay, and there you go, the concavity is up. So far, all the predictions are coming true, guys. Now here, you have a point of inflection. How do I know that? I know it's a point of inflection because it's square root of 2 divided by 2. Yeah, at square root of 2 divided by 2, the second derivative is 0, but the first one is not. So it has to be a point of inflection. If it's a point of inflection, that means here you have a concavity down. Okay? Now let's see. You have a concavity up and a positive slope. So it's like this. And then you get a concavity down. So it's a it's still a positive slope. The slope in here has to be positive. But I'm just predicting this. I want to make sure that I'm assuming this stuff. So let's try, okay? Let's test first the slope and then the concavity. In here, it's a number between 0.0, I'm going to put 4 divided by 5. It's within here, okay? So let's go again. Minus 15, I'm going to do here, minus 15 times 4 divided by 5 to the 4th. So it's 256 divided by 625 plus 15. 4 divided by 5, so it's 6 squared, 16 divided by 25. Alright, now here's what I'm going to do. I'm going to use calculator again. So you got a 15 times 256 divided by 625. You got a negative 6.144. So this equals negative 6.144 plus, you got 240 divided by 25, 9.6. So it's positive, okay? If it's positive, the first derivative is positive. There you go. Look at that. The slope is positive. Now let's see if the concavity is down. If the concavity is down, when I plug in 4 divided by 5, in here, it has to be a negative number. So, I just like to erase all these little specks that are left behind. So, minus 60 times 4 divided by 5 cubed. So, it's 64 divided by 125 plus 30 times 4/5. Okay, so this is going to be negative, let's see, 60 times 64 divided by 125. Going to be 30.72. And then you have this. You divide this by 5, divide this by 5, get a 6, get 24 plus 24. So minus 30 point something plus 24. This is going to be negative. If it's negative on the second derivative, the concavity has to be down. And look at that, the concavity is down. Now, if the concavity is up here and it's down here, this is a point of inflection. All the predictions were true. Okay, now let's see 1. 1, the first derivative is going to be 0, okay, but the second one will not be 0. So I know that this is a point of inflection. Right? Right. Now, if this is a point of inflection, for this domain here, the concavity has to be up. Now let's visualize this stuff. Here you got a concavity down and a positive slope, so it's like this, and then it starts being a positive slope in here, okay? Because you see, guys, if you do this and you do that, then this is not a point of inflection. This is a minimum, it's a maximum, okay? And this concavity right here is down. So you can't have that. You have to come with a down concavity and a positive slope. You have to come to 0, and then the concavity has to be up. That means that you gotta have a positive slope too. So let's see here. The slope I'm predicting is gonna be positive. So let's see if it is. I'm just gonna use the value 2, okay? So in the first thing here, it's gonna be minus 15 times 2 to the 4th, which is 16, and then plus 15 times 4, because it's x squared, okay? This equals minus 240 plus 60. It's negative. If it's negative in the first one, okay, oh, look at that. Look at that. If it's negative in the first one, the slope has to be down. Okay, that's not what I was expecting. The first tangent is 0. Oh yeah, no, I made a mistake, guys. This cannot be a point of inflection, because for this to be a point of inflection, 1 has to be 0 in the second derivative, not in the first. I'm sorry. Yeah, I guess I'm getting too sleepy. So let's see what's going on in here. 1 makes the first slope is 0, and the second one is not 0. So this is a maximum or a minimum. Okay. Now here's the thing. This is a maximum or a minimum. Now here's the thing. You got a concavity down and a positive slope. Since it has to be a maximum or a minimum, it cannot be like this. Okay. It has to come and it has to go down. So I know that in here, this is a maximum. I'm going to put max in here. And this one here, it has to be, the concavity has to be down and the slope has to be negative. We already found out that the slope is negative. Let's see if the concavity is down. Actually, I'm going to try for 1 to see if it's a maximum. If it's a maximum, the second derivative has to be negative. So let's see here. So you have, well, let me think. Yeah, that's strange. Well, 1 times minus 60 plus 30, which is minus 30. Okay, so I said that in order to be a maximum, okay, the second derivative at 1 has to be negative. And it is negative. Okay. Now, we already noticed, if you go back in the video, that this is already proven here, that the first derivative, when you put a 2 in here in this domain, okay, the first derivative is negative. We already proved that. Now, what about the second one? I'm going to put 2 here. So it's minus 60 times 2 to the 2 cubed is 8, plus 30 times 2 is 60. Okay, This is going to be minus 480 plus, so this is going to be negative. If it's negative, the concavity has to be down, and look at that, the concavity is down. All right. Now, let me just think here for a second. Since we already got all this, I'm going to erase this stuff. I'm going to erase this, all this sketch. Grab this thing here, bring it down. Bring it down like that. Now let's see. This is messed up. So what are the critical points? -1. So I'm going to put -1 here. This is -1. Yeah, -1. I'm just going to put here -1. And then you have minus square root of 2 divided, well, okay, so hold on. I'm going to make this -1 a little bit further so that so this is the -1 when x is -1. And here I'm going to put kind of like that, which is minus square root of 2 divided by 2. And then you have 0. And then you have here square root of 2 divided by 2. And then you have 1 here. 1. Okay. Concavity up, slope down. And this is a minimum. So concavity up, slope down. Yes, so it goes like this. And since -1 is a minimum, you got a concavity up and slope positive. Look at that. You go here. And then over here, you got a point of inflection. Okay, it's not perfect. You got a point of inflection here. At 0, you have another point of inflection. Man, this, I'm not going to be able to do this. So -1 is minimum. Minus square root of 2 divided by 2 is a point of inflection, which starts going like this. Okay, so you got a concavity down, a positive slope. And then at 0, you have a point of inflection again. Okay. Okay, so it's like this. It's just that you have another maximum here. Minimum, maximum at 1. Let me see here one thing. Oh no, yeah, actually you don't have this. Okay. Because the graph is not exactly like that. You know, in fact, instead of trying to sketch the graph, because in order to sketch the graph, you also had to go to f of x and you had to plug in numbers in here within all these domains to find out the points, right? Like there's going to be a point here, there's going to be a point here, there's going to be a point here. I'm not going to do that. So I'm not going to sketch the graph, because we're going to have to do even more calculations to sketch the graph. I'm just going to copy the one from the book, paste here. Okay. I'm going to be dragging this around. Okay. So let's see here. From negative, I'm going to do this, and I'm going to do this to make it even easier for you guys to see. So from negative infinity to -1, you got it's this part. So you got a positive concavity, an upward concavity, and a negative slope. You do. And then you have a minimum here, -1. Then you got a positive concavity, an upward concavity, and a positive slope. You do. Then at 0, you got a point of inflection, right? Which is not a negative or it's not a minimum or a maximum. It's just a point of inflection. And you do because you have a negative downward concavity and then an upward concavity. And here you go at 0. You got before a downward concavity and then an upward concavity. the slopes are positive on both sides, and they are going up and then going up. At square root of 2 divided by 2, which is this point here, okay? At this point, guys, you're gonna have, at this point here, you have a negative square root of 2 divided by 2. It's here, okay? Can you see the arrow moving here? It's here. You got a upward concavity to a downward concavity. And here's the same thing. You got an upward concavity to a downward concavity. So this is up and this is down. Okay, so square root of 2 divided by 2 is right here. And then you have a maximum here at 1. And at 1, look, over there, I said that it was going to be a maximum. And after that, you have a negative slope and a negative slope and a downward concavity. And you got a downward concavity. Look at that. Okay, I just didn't sketch the graph right because I did this. I did something like this, right? But it doesn't go here. I had to actually plot all these numbers. For example, go to f of x, not the first derivative or the second derivative. Actually go to the function and plot. For example, minus 2, when you're doing a minus 2, you're going to have a point way up there. Okay, what about when you have negative square root of 2 divided by 2? Then you got a point here. What about when you have a minus 1? Then you got a point here, minus 2. I was going to have to put all these points in order to correctly sketch the graph. But you get the point. You know, I found out all the critical axis and where the concavity is upward or downward, where the slope is up or down, the points of inflection, the minimums and the maximums, and it just works. Yeah, now I'm gonna stop the video because on the next video I'm gonna show you guys going to limits. Remember, when you have a graph like this, it goes down as it goes to negative infinity. As x goes to negative infinity, it approaches a limit. As it goes to positive infinity, it approaches a limit. Something kind of like this. Okay, or yeah, or maybe like this. So it approaches this limit here, which is a horizontal asymptote, or it can the graph can do something like that, like crazy, like this. Okay, so you know that this is gonna approach here, and then you got something like that. So this goes here, yeah. So you see that as x goes to positive infinity, the y is also going to positive infinity, but it approaches an asymptote in here. Okay, and as x, well, the x could come here. And as it approaches negative infinity, the y is also going to approach negative infinity, but it will approach the asymptote right here, like that. Okay, and this is what we're going to see in the next video. So since it's a different topic, I'm just going to go to the next video with this one.